All right, here's another work problem. It says here in example 6, the Honeywell air cleaner can clean the air in a room in 15 fewer minutes than it takes the blue air purifier to do the same job. Together, the machines can purify the air in 10 minutes. How long will it take each machine working alone to purify the room? So this is another work problem where we have two different machines that can do the job alone, or working together, we can figure out how long it takes them to do the job together. Well, in this problem, we actually know how long it takes them to do it together. We want to figure out how long it takes each of the machines by themselves. So we have to kind of use this idea backwards. Now we still have the same kind of formula that we can set up the work problem with. We have the time it takes for the Honeywell air cleaner plus the time it takes for the blue air purifier equals the total time it would take for them to do it together. All right, let's plug in our information. So it says here that the Honeywell air cleaning machine does it in 15 fewer minutes than it takes the blue air. I'm going to call blue air B. We don't know how long it takes blue air B to do the job, so we're just going to keep it as that variable. But we do know that it takes the Honeywell air cleaner 15 fewer minutes, so I'm going to take that amount of time and subtract 15 from it. That's how I got the B minus 15. So this is the amount of time that it would take the Honeywell air cleaner. It's whatever B is minus 15 minutes, 15 minutes fewer than the blue air. We don't know how long it's going to take the blue air. That's why I'm going to keep that a B. And we do know how long it takes them together to do the job. Remember, it was 10 minutes? So that's how I set up this equation. Now I have a rational equation with different denominators for each piece. I can go ahead and find a common denominator, and then we can solve and figure out how long it will take each of these cleaners to do it by themselves. It looks like this first fraction is missing a factor of a 10 and a b, so that it has a 10, a b, and a b minus 15. The second fraction is missing a 10 and a b minus 15. And the last fraction looks like it's missing a factor of a b and a b minus 15. All right, now that my denominators are the same, they all have a 10, a b, and a b minus 15. Once my denominators are equal, I can go ahead and worry about the numerators. I can set them equal to each other, and so I end up getting this new equation that I can now solve. I can distribute the 10, I can distribute the b, and I end up getting something like this. I've got some b's, I've got some b squareds, I've got some constants. It looks like this is a quadratic equation, so I'm going to start moving everybody over to the same side and see if I can solve it that way. I'm going to move the 20b over to the right side by subtracting it. I'm going to add the 150 over to the other side, and I end up getting a quadratic equation that looks like this: b squared minus 35b plus 150. This is now a basic factoring problem where I can figure out what numbers multiply to 150 that add to give me negative 35. You might have to try a few numbers, but I ended up getting negative 30 and negative 5. They multiply to positive 150 and add to give me negative 35. Now that I have factors set equal to 0, I can set each of them equal to 0, and I can solve, and I end up getting b equals 30 and b equals 5. Now let's talk about what it means though. Remember that b represented the time that it took blue air to do the job by himself, right? And since my units were in minutes, then that means b equals 30 means it would take blue air 30 minutes to do the job by himself. Or b equals 5 would mean that it would take blue air 5 minutes to do the job by himself, that cleaner. But remember, the question is also asking us for both machines. So we don't just want to figure out how long it will take blue air. We also want to figure out how long it's going to take the Honeywell air cleaner to clean the air. Remember that it took the Honeywell air purifying machine 15 minutes fewer than the blue air. So if the blue air took 30 minutes, can I subtract 15 from that to figure out how long it would take Honeywell? Well, if blue air does the job in 30 minutes, well then it should take the Honeywell air purifying machine only 15 minutes to do the job. If blue air took 5 minutes to do the job, and I try to subtract 15 minutes because it takes Honeywell's machine 15 minutes less than, don't I end up with a negative number? And it doesn't really make sense for the Honeywell machine to do it in negative 10 minutes, right? And so that's one of our extraneous solutions for this particular word problem, right? I mean, it works, but it doesn't make sense in context of the problem. So really, only the 30 and the 15 are the values that make sense in the word problem that we have here. So it looks like it's going to take the Blue Air machine 30 minutes and the Honeywell machine 15 minutes to do the job all by themselves. If they work together, though, remember, it only takes them 10 minutes. Those numbers should make sense. They should be longer by themselves than they are together, right? So make sure your numbers make sense. All right, why don't you go ahead and practice this one? Now that we've done a couple, why don't you pause the video, take a few minutes, and see if you can figure out how to do this try it problem. All right, it says here, Kara and Brooke can complete a task in 15 minutes. Working alone, Brooke takes 60 minutes. How long will it take Kara working alone? So we don't know how long it's going to take Kara. Can I call that C? We do know how long it takes Brooke, and we know how long it takes them to do it together. So let's fill in our formula with that information. I ended up getting 1 over 60, that's for Brooke's time, plus 1 over C, Kara's time alone, equals 1 over 15, the time it takes them to do it together. I now have a rational equation that I can find common denominators and I can solve. It looks like my common denominator is 60C, so the first fraction needs a C, the second fraction needs a 60, and the last fraction needs what, a 4 and a C? So that everybody has a common denominator. Once my denominators are the same, I can go ahead and worry about the numerators, and so now I have an equation that looks like this. I can subtract C from both sides, and I can divide, and I ended up getting C equals 20. Okay, what does that mean though? What did the C represent? Well, didn't the C represent the amount of time it was going to take Kara to do the job by herself, which is what the question was asking, right? And so we can say that it's going to take Kara 20 minutes to do the job all by herself. Hopefully you got the same answer, making sure that you can show me your setup, your equation, all of your work, so I know how you got that answer.